prove that for integer n, if 3n plus 2 is odd, then n is odd. Right, so we're going to do this as a proof by contradiction. So I'm going to write that down. Proof by contradiction. You should always say what you're trying to do. So it's written as an if and then. So if 3n plus 2 is odd, then n is odd. So we're going to assume that the conclusion, as in the n is odd, we're going to assume the opposite of that. So assume or suppose that, assume that n is even, and we're still going to assume that the 3n plus 2 is odd. Okay, so if n is even, that means n could be written as some 2k, where k is an integer. So now all we really need to do is get an expression for 3n plus 2 using our new n, that's 2k, and if we can show that this has to be even, we've shown a contradiction. So 3n plus 2, well, we've just said that n is 2k if we're assuming n is even, so that must be 3 times 2k plus 2. 3 times 2k plus 2 is 6k, equals 6k plus 2. I want to show this is even, so I'm going to pull a 2 out of this, equals 2 times 3k plus 1. So that is equals 2 times an integer, because we know that k is an integer, so 3k must be an integer, 3k plus 1 must be an integer, so whether it's odd or even, once we times it by 2, it will definitely be even. So 3n plus 2 must be even if n is even, but we know that we know that 3n plus 2 is odd. Okay, so it sounds like a contradiction, because we know for sure that something is odd, but if this was the case, then this something that we know to be odd would be even. So we have a contradiction. Here we have a contradiction, and n must be odd. And that's it, proof by contradiction.